Great. So welcome everybody to the BioCAD Wednesday, or actually Tuesday workshop. My name is Antonio. I'm one of the design fellows at the CEID, and it is a pleasure to be co-hosting this with Anusha, a good friend and also a leader of Y-BioIncubate. I'm not quite sure what your position is, but I'll let her introduce herself and then kick off the workshop.
Hey, sorry I had to turn my video off. I'm Anusha. I'm a senior in BME. And thank you to everybody for being here. We're really excited to talk to you about CAD for biomedical applications. I run a group on campus called Y-BioIncubate. It's a group that's dedicated to bringing more industry involvement. So that's kind of like biotech industry, medtech industry, anything that's biology involved to undergraduates. And so this is a field that I want to go in. I love medical devices. I love biotech. If you have any questions about that, feel free to email me or ask me. But for now, welcome to the workshop, and let's get started. I'm sure if you all are here, you have heard or know what computer-aided design is, but just briefly, it uses computers and specialized software to model parts in 3 dimensions that can then be optimized, analyzed, 3D printed, or machined. So before we had computer-aided design, a lot of the mock-ups that we would do and the designs that we would do would be totally blueprints. So every time you make a part, you would have to draw it out. Every time you make a modification, you would have to draw it out. Every time you did some sort of simulation, you would have to put all your coordinates into the computer and write a super complex code to analyze what would happen to it, to your part. Now that we have computer-aided design, we can do all of this a lot easier. And it's completely transformed a lot of the industries that we rely on every day. Mechanical engineering, definitely, and biomedical engineering. CAD has found its place in a lot of different spheres of the biomedical industry, and is used for a diverse amount of applications. Again, please stop me if you have any questions on this, just unmute yourself. The first application is with physicians. And so what CAD allows us to do is actually look deeper at patient morphology than we could have if we just looked at a picture. The way we do this is that we can take a lot of stacks of images of something that we want to look at. For example, a bone. I would take 100 images of this bone, spanning from the top of the bone to the bottom of the bone. Then I could put it in a CAD software and do a little bit of analysis and could see the full shape of the bone. You can rotate the bone if you do that. You can look at what's going on the inside of the bone. This kind of helps physicians diagnose this hidden patient morphology that might happen, and then prescribe the correct devices to do any fixes that need to happen. Second application, as we all know, is in engineering. That's just modeling and simulating medical devices. For example, maybe I want to create a heart valve. Really cool. What I could do is I could design all those components on CAD software, put those together, and then if I wanted to, I could simulate blood running through this valve. Or I could simulate this valve being bumped around many times as a person goes on the run. So modeling and simulating medical devices is much easier to do on CAD than it is on paper, as I mentioned before. Another cool application is in bioprinting. Bioprinting is taking cellular ink, which is a combination of cells, maybe some gel, and some stuff that knits the cells together, and putting it in a 3D printer. When we bioprint, we can create shapes. So we can recreate organs or tissues that could then be implanted inside the body. This is a newly emerging area of research, but it's predicted to be super awesome in the next decade. Biomanufacturing also has applications with CAD. Whenever we design drugs, we need to make them at large scales. We can use bioreactors to do so, which are just special devices that will culture cells and culture drugs at the right temperatures, at the right concentrations. And so CAD can be used to create these biomanufacturing machines and simulate these processes. An application that you wouldn't really think of is in genetics. So all these softwares have been emerging called genetic CAD. This is a little bit complex, but the basic idea is that in GeneCAD, It's giving you a bunch of different genes that you can put together. And once you put the different genes together, you can simulate biological processes. Really cool. I have a picture of it on the next slide, so we can talk a little bit more about that. And last, as I already said before, industry is super involved with CAD. Specifically in orthopedics, a lot of companies are working to create customized implants for patients. How this works is that a physician will take a 3D model of some sort of bone or an organ that they want this customized implant for, and they'll send it to the company. The company will use this and design something to fit specifically that physiological feature that the doctor sent over. So this kind of paves the way for more of like a personalized medicine approach. You probably hear that kind of buzzword in a lot of modern day medicine, personalized medicine. This is kind of the first step. So just to briefly talk about some of the applications, let me see if I can use my pointer. I don't think I have a pointer.
Okay, we can see mouse.
Wait, sorry, Google Docs lets you use a pointer. I think I got it. Do you see it?
Yeah.
The little red guy. Yep. Over here on the left, we see this customized implant that I was talking about. The red here is the top of a bone. And basically what these engineers have done is taken this metal device and put it right over the bone. So this is a knee replacement, actually. When you've probably heard of older people getting knee replacements, basically what happens is that the fluid stuff between your knees it's depleted or it breaks, and your knees can't really move as they did before. There's a lot of friction. And so engineers use metal to kind of mitigate this. This is just part of the knee implant. They go over it and it allows smooth interaction between the joints. So that's one use. Over here, what I'm circling is a prosthetic. I think a lot of you have probably heard of prosthetics. They're just substitutes for arms or legs whenever we need them. You can use CAD to model these. It's very useful as prosthetics are super complex. So you can put all the parts together in CAD and it will be much easier for you to analyze things. Over here, we have a picture of genetic CAD. Specifically, there are actually a lot of diverse genetic CAD applications. This one specifically is called Cello CAD. What it does is that you can pick some genes and you can essentially put them in a logic circuit. So you're putting these genes together like they're some sort of circuit. And with these circuits, you can simulate them with the CAD and see what your chemical outputs are. And so that's what this shows over here. And so you can experiment with different types of genes. You can drop them in, create different types, and see what kind of chemical outputs you're getting. Okay, and lastly, on the right here is a 3D printed ear. This is super cool. This is the bioprinting that I was talking about before. These scientists at a company called Aleti, which creates bioprinters, were able to use cartilage cells. So that's the stuff that your ears are made of. They were able to put these cartilage cells into a 3D bioprinter, and using a CAD model of ear, they were able to reconstruct the ear on a petri dish. Full disclaimer, this is not a working ear. It's just like a model of the ear with cartilage. Still pretty cool in my opinion. Now for the topic of this workshop, stents. What are stents in the first place? So you can see a stent described on the left right here. The stent is this wire mesh tube that you see, and its purpose is to hold small, smooth muscles in place. Essentially what you do is if you have a blockage in your vessel, so that could be because you have heart disease, because you have a lot of fat, or maybe just because you have some sort of block. You put the stent where the block is, and then you use some sort of mechanism, whether it's a balloon or the material itself, to push the vessel back open to its normal diameter. Because the stent has a mechanical property, it holds the vessel open, and that allows whatever you want to flow through the vessel to continue flowing through the vessel. Most often it's with heart attacks and blood. So if you have it's to prevent heart attacks, you have to find clots in the body and push them open. So you can put a stent in there to do that. And that ensures you have normal blood flow in your vessel, preventing the heart attack. stents pretty much anywhere in your body. They're used in the lungs, they're sometimes used in the brain, and sometimes used in your intestines. Here are just a couple of quick facts about stents and stent replacement. On average, it takes 5 years before a stent goes bad or before it gets covered in yucky stuff from inside your body. So that's the average lifetime of a stent. However, the average age of people who get stents is 65 years old, right? So thinking about what this average lifetime of 5 years, that's not that great. You don't want to do a lot of operations on people who are very old at risk that they could like die or bleed out, anything morbid and depressing like that. So there's been a lot of effort put into improving stents in the last like 70 years. And 2 million Americans undergo a stent placement procedure every year. So as you can see, it's pretty crucial to our society's health. And it's like a pretty standard device that's used in hospitals. There are 2 main types of stents, many, but these are the 2 main ones. First one is drug-eluting stents. These are made of plastic. They're a newer stent. They've been invented in the last 10 years. And society has been more so trending towards these drug-eluting stents. They're still very much in development though. So they look like a stent. They're just made of plastic, or they're metal coated with plastic. And inside this plastic, you have some sort of a drug, such that if you had a patient with heart disease, for example, you could put the stent in the vessel and the drug would release over time, causing less likelihood of that patient having a heart attack. The other type of stent is a bare metal stent. So this has nothing on it. This is just a wire mesh. Nowadays, they're made of a metal called nitinol, and it's a very special metal. It has the property in that it expands naturally at body temperature. So I didn't describe this before, but the way that you put stents in the body is that you have to inflate a balloon to inflate the stent. When you have nitinol, though, you don't have to do that. So it's a very easy procedure. All you have to do is put it in the body and it'll blow up by itself. There are a couple of design aspects when we think of stents. And they're not too complicated in general, as you can see. Stents kind of just take the same form, but you should pay attention to these 4 factors when you're thinking about what kind of stent you want to design. The first one is a mesh cell. That's labeled in O1 here. It is the basic unit of the stent. There are many repetitions of these in one stent. They can take many forms, as you see. These all happen to be of like one type. Maybe you'll have 3 bumps in your mesh cell, maybe you'll have 1. But whatever the geometry is, it determines what the mechanical properties are of the stent. The second is the connector, shown in O2. As I said before, you have many repetitions of this mesh cell when you have a stent. So you have to connect them somehow, right? The connector does that for you. Sometimes they're straight, sometimes they're curled. That gives the stent greater flexibility. They come in many forms. Third component is the cell offset. You can see it in O3 there. It determines whether your cells are symmetrical. So technically, I could take all these mesh cells and I could stack them on top of each other, and that would be an okay stent. But over here, you can see that they're offset. They're not stacked on top of each other. You can see a line. You can see that they're offset by like 1-ish unit. Most stents are offset just so that the mechanical properties are distributed equally, but some stents, especially drug-eluting stents, just because they need to cover more surface area, will be non-offset. Last factor is the most important for stent stability, and that's strut thickness. So that's the distance from the inner diameter of the stent to the outer diameter of the stent. And studies have shown that even if it's like a little bit bigger than the norm, it could be completely different on how your stent reacts. It could have a totally shorter lifetime, it could have a totally longer lifetime. So when you're actually doing stent design, these are some things to consider. We're obviously going to take a little bit more of a simplistic approach here today. Now for the workshop, before we start, let's just walk through the workflow that we'll take today for designing this stent. So first, we're going to create our mesh cell. Antonio has laid out some dimensions that are very easy to create the mesh cell with. You can also create your own if you're super comfortable with OnShape. After we create this mesh cell, we pattern it horizontally to make our columns. We pattern it vertically, and then we'll have some sort of like metal sheet. Luckily, we wrap the sheet around into cylindrical form, and that creates our stent. So let's get started. Let me stop my share.
Can everybody hear me okay? Just give me a thumbs up or something in the chat. Great.
I can hear you.
Awesome. Thank you, Nusha. You were cutting in and out a little bit, but we got most of it, I'm pretty sure. And hopefully everybody else got it.
Oh no. Okay.
No, but we heard all of it, and the slides were fantastic, so we're really excited. So I'm gonna go ahead and share. And let me get started. Great. So this is what my OnShape looks like. Quickly, by just show of hands, and I'm gonna get rid of this. Great. Quickly, by show of hands, can you give me just like a thumbs up if you have used CAD before, whether it was SolidWorks or OnShape or anything like that, just so that I can sort of get a feel for the crowd. Great. What about if people have used specifically OnShape? Switch it to a clap or any other emoji. Great. All right, so if you have familiarity with OnShape or CAD in general, hopefully what this will be is an introduction to a different way of doing things. We're going to be using some functions today that you wouldn't normally use, such as the wrap. And I personally don't usually use the linear pattern function, both in sketches and in features, but we're going to be using a lot today because stents are inherently very symmetrical, very repetitive. So we're going to be leveraging a lot of those tools. So go ahead and open up OnShape. It'll be helpful definitely if you have a second monitor, but if you don't, you can do a split screen, or I'll leave enough time in between each step to hop back and forth. As you can see right now, I have a bunch of documents that exist. And if you aren't familiar with OnShape, really quickly, it's very, very nice for, some people describe it as like the Google Docs or Google Drives of CAD, because you can literally open up different documents at the same time, save things within a folder that represent a document, share and co-edit things. So it's really good stuff. I'm going to go ahead and create a new document. I'm just going to call it stent, or actually BioCAD workshop. You can call it whatever you want. And that'll let us open up a brand new part. So give me a thumbs up if you're following along, you've got that. Awesome. So as you can see here, we've got several things that are available to us, a bunch of options up here on the top bar that gives us different things that we can start to do. We also got this workspace in the center here. The main thing to focus on especially if you've worked on with CAD, the same people who created SolidWorks, the same people who actually founded OnShape a couple of years ago. So it's actually there's a lot of similarities between the two different platforms, and there's even some settings that you can configure that literally say like use SolidWorks settings. So if you're really, really comfortable with SolidWorks, you can activate the SolidWorks settings here to make everything look similar. What we're going to do first is up here in the top left-hand corner, I'm going to click on the three little lines, the little hamburger menu, and click on workspace units to change this to from inches to millimeters, just so that we're all consistent. Usually I'm not going to have like a 6-inch stent that's really, really massive. I don't have blood vessels that big, so I'm going to switch it to millimeters. We have a little bit closer to the right size of stent. What size are stents actually, Nusha? That's something I don't know.
Yeah, so blood vessels can range in what size they are. I would say probably like a 5 millimeter diameter is like maximum. Often that your clots are occurring in like your carotid arteries, which are much larger than your other arteries. Cool.
All right. So as you're here, to spin this around, if you have a mouse and you click the scroll wheel, you can actually click it or hold it down and then rotate the view like that. If it's not working out for you, you can obviously zoom in and zoom out. And to move it around, you can also leverage this menu right here on the top right, which actually lets you spin this cube around either by clicking these little arrows here, or you can actually click a face altogether to rotate it the way you want. Either rotating it like that, you can actually, I think, move the cube that way, yeah, and click the front menu like that. So just to practice, just to make sure you're comfortable with using OnShape, what we're going to do is just extrude a shape and then cut something through it, just so that everybody can do that. So I'm going to go ahead and click sketch in the top left corner here. And again, stop me if I'm going too fast or if I'm going too slow. And then we're going to just click any plane that we want. In my case, I'm going to click the front plane. And what it'll do is activate a sketch that's now parallel, actually coplanar with the front plane. What you can do is actually you can right click it and click down here where it says view normal to sketch plane, and it'll give me a direct head-on view perpendicular to it. Or if you feel like this, you can actually just click front up here in the top right. You should be able to see that just like that. From there, you can then click any of these sketch options. So for example, you can get a rectangle. We'll just select any size rectangle here. In this case, I made it too small, so I'm going to drag it out here. You can use this dimension feature up here in the top middle-ish, and then you can also use the shortcut D. Click that, and you can define a dimension for it. So in this case, the dimension that we have here is going to be 90 millimeters. And then you can also say you want to cut a little keychain. You can cut a hole right here by drawing a circle. So there's a circle menu right here. The keyboard shortcut is just C. And so there you have a finalized object that you can extrude or do something to now. And you know that it's closed, or you know that it's finished because it's actually filled in with this dark gray view. Only when something is filled in with dark gray is it able to be extruded from there. So what you can do there is click check mark. There you have this sketch that it's in the front plane. Now what you can do is hit extrude and click that sketch. And then it'll preview something for you to extrude. And you can see that it even has the little hole in there. So let's say we want this to be exactly 15 millimeters big. Click the check mark. And now you've got this cute little keychain. Thumbs up for everybody who this is redundant for or was able to do this. Awesome. So, so we're going to go ahead and just delete that. You can right click it and delete it. Then you can also delete the sketch. And we're going to get started with our stent. So as Anusha said, the first step is to create the mesh unit. So what we can do, I'm going to go ahead and click normal to the front plane. It's arbitrary, but I like using the front. And I'm going to hide the right and the top planes. And you can actually do that by clicking hide top. If you hover over it on the left menu, you can just click the little eyeball and then click the little eyeball on the right, and then it'll hide those. So the only one that's visible is the front plane. Once you do that, what we're going to do is start a new sketch, and then you have to click a plane again to select where you want to draw. So I'm going to click the front plane. And then from there, we're going to set up a boundary for like a quarter of a unit of our mesh cell. So what I'm going to do is click on this rectangle option here and click the center of the origin and just drag this out until some arbitrary feature. I'm going to click the dimension feature here. And I'm just going to make this 2 millimeters big, 2 millimeters. You can specify 2 mm, or you can just write 2 since we changed our units earlier. You might have to actually zoom in a lot because it assumed that we are working with bigger units, but we're not. We're working with small units. And I'm actually going to hide the front plane now so that all we see is this. Now, anytime you actually click this little cube over here is very useful. Over here in the top right, if you click it, it'll actually zoom in for you so that everything is shown. So if I shorten this dimension here, so it's a little closer and it's hugging the square, and now I click front, it'll actually put it nice in the center for me. So it'll zoom in for me. So that's nice. So everybody, thumbs up there.
How do you actually get the dimension using the dimension tool?
How do you get the dimension, you asked?
Yes.
So you just click this dimension tool right here. It should be next to where it says DXF. You can also use the keyboard shortcut, just D.
Right, and how do you specify the number 2?
So that if you click something, so I'm going to delete this dimension here, for example, by delete this. Cool. So to specify the dimension, you click the D, and then you click the place you want a dimension. Click it once, and then it should let you type it in. But if you say you typed in the wrong thing, so you wrote in like 3.14, you can actually double click it again on the number and just type in what you want.
Cool, thank you.
That work for you? Great. Awesome. So from now, what we're going to do is start to design our mesh stent. So now that we've got this boundary, and as a side note, anything that's in black means that it's fully fixed, right? There's nothing you can do to change what level what dimension or angle those designs are at. If it's blue, it means it's still unconstrained and you can still edit it around. So that's just something to know in case you're wondering why some lines are black or some lines are blue. So in our case, if you click this line function right here, which is over here in the top left line next to the square, if you now hover over it, you see that your cursor has changed to a crossbar. And then if you hover over this left line, right around the middle, you should see a little yellow square pop up. That means that we're actually hitting the midpoint. So if you click it once, you should see a line be able to drag out anywhere you want. And so now that is fixed to the midpoint. That's constrained to the midpoint. And we're going to leverage a lot of these midpoints and symmetries of the square and different lines to accomplish our design. So if you go over to the top line now and hit this midpoint, you should connect there, and you should be able to keep dragging some lines out. So I'm going to drag it down now to this midpoint. And then if you want to be done with a line, what you can do is hit escape, or you can just click the line feature again. So you should have this little triangle top here. What we're going to do now is click the line again, or click L on the keyboard. I'm going to click the lower left-hand corner there, drag it up. Now, what you can also do is if you find a point, before you click it, if you find a point that you want, and then if you slowly start to drag it to the right or to the left, you should see a couple of yellow dotted lines sort of guiding you towards the right. And what that does is it fixes it using sort of like a relation to constrain that line. So in our case, we're constraining this to be exactly horizontal to that midpoint. I'm just going to keep dragging it out there. I'm going to go until it finds right there, and it clips on, or what's it called? It sort of like magnetically hooks onto the midpoint of the top line too. So I'm going to click right there. So now if I actually line this up, you should see that it's 1 millimeter long and it's perfectly vertical. So that's great. And then I'm going to attach it to this bottom right-hand corner there. Sweet. And we're still fully constrained. So this is like a quarter unit of our mesh that we're going to make. Any questions so far? Great. So let's keep going. What we're going to do now is make sort of half of our unit. So, we've got this simple edge here, and this would be a pretty sharp stent to put inside of something, but we're going to keep it simple. What we're going to actually go to is this linear pattern. You should see these little four little squares right here. If you click on linear pattern, if you hover over it, it'll tell you exactly what you need to do to click it. Hover over it like that. But basically, we're going to select the tool, or basically what we want to pattern, and then we select, specify how many times we pattern it and how far away it should go. So in our case, I'm going to select this line, that line, and that line. So we've got our triangle there. You don't see anything yet, and the reason for that, if you click front, is because it's very, very far away. It's specified 25 is the default. So I'm going to actually just drag this over, or you can double click it, and let's just write in the number 2. Hit enter or return from that. And I specified 2 because we know that the width of one of our units is exactly 2 millimeters long. 2 millimeters long. So if we just write 2, this is saying that the distance of each repetitive pattern should be 2. And then here where it says 3x, you can double click that. This is just it specifies how many times you want it to repeat. So in here we can write 4, hit return or enter, and then we should have 4 little lines like that. And then don't click this check mark here. That's to finish the sketch. To finish this out, just click left click, or click anywhere in the white space, and it should give you 4 sets of black squiggly lines. What's up? It's closed. Sorry, guys.
If you all have any questions, I'm monitoring the chat. You can feel free to DM me or just DM the general chat.
Sorry about that, y'all. We're still in the CEID. We're live. Okay, great. So thumbs up. People are able to do that. Great. Love it. Love to see it. So from here, we've got, this is, about half. This is like 45% of one unit cell. So what we're going to do now is move on to step 2, which is create our connector, which Anusha talks about. What we're actually going to do is only create half of our connector, because we're going to leverage the repetitive and mirroring functions of OnShape to create the rest of it. So what we're going to do is click this line over here, and then I'm going to find the bottom left-hand corner of this box and just come down a little bit. You can go up, down a kind of arbitrary amount. And then I'm just going to click and then drag it left. Now, if you aren't sure that you're going to hitting exactly horizontal, what you can do is just get close to where you think horizontal is, and it should snap to it right there. So I'm just going to click it right there and then hit escape to get rid of it. So there we've got an unconstrained blue line floating out in space. What we're going to do is click that line, and then over here in the top, you should see an option that if you hover over it, it says construction. And the keyboard shortcut there is Q. So you can just hit Q or click that button right there, and then you should have a constructed line right there to right here. Thank you. So now, actually click construction, and then to get rid of it, click away. We're going to hit the dimension, smart dimension up here, and then I'm going to click this bottom line here with, of the square, and then this dotted line right there. We're going to specify that this is exactly 1 millimeter away. Everybody following along? I know we had a little bit of a disruption there. Awesome. I'm going to take that as it is. And actually, I lied. We're actually going to make this 0.5, so a half a millimeter away. because when we mirror it over, it's going to equal exactly 1 inch. And then from there, we're going to make another line, and I'm going to pick this center diagonal right down here to make sure that we got that. And I'm going to click basically just pick any arbitrary spot. Don't click the midpoint though, because that will create a constraint that we don't necessarily want. So I'm just going to click, somewhere between the midpoint and the bottom of that angle, and just click it, make sure it's vertical, and then drag it down to that dotted line. I'm going to drag this line over there, and then drag this up again, make sure it's vertical, and then hit escape. So now you should have this sort of weird looking connector there. What you can do is we can use these features called relations or constraints to specify different relationships between different lines or features in OnShape and CAD. So in here, if you click this little drop-down menu, you should see a line with a dot with another line coming out of it. If you come down and then find where it says equal, this is a constraint where we can specify two things by clicking both of them at the same time. That let us say, if the dimension of this thing changes, if A changes, also change B so that they're exactly equal to each other no matter what. So we hit equal, and then we come down here and select this line, and then it's saying, all right, what should it be equal to? You can select that line. You should see them change so that they're always equal to each other. So I'm going to go ahead and click equal again to get rid of that. And now they're still blue because they're unconstrained, but basically, if you were to drag one of these blue lines out, you should now see both of them start to move and change so that they're always equal to each other. So what we can do now is click on the dimension and click the line, click any of these dots. So I'm going to click the line and then this middle dot over here, because I think that's nice to see. And I'm going to make this a 3/4 of an inch, so 0.75 millimeters, millimeters, not inches. So that it's a nice sort of skinny connector point there. Everybody got that? Sweet. Storm said yes. Is anybody trailing behind or confused?
What was the last step you just did after the equal?
Basically, I clicked the dimension, and then I clicked one of the lines, and then this midpoint of this unit right here, and then specified that it was 3/4 of an inch away.
Got it.
Great. So let's keep going. Now what we're going to do is, before we mirror it, we're also going to want to create the connector for the back piece. So there's connector that connects the meshes internally, and then there's connectors that connect each mesh to each other. So what we're going to do is draw another set of connectors. But as Anusha mentioned, there's there's like the ones that are not offset, and then there's ones that are offset a little bit. We're going to offset ours just a little bit. So pick the connector that's all the way to the right. We're actually going to do something before we do that too. So I'm with the line tool selected, so L. Actually, get rid of the line tool. What we're going to do is leverage the mirroring function. So over here, you should see an option that says mirror. So it looks like two lines mirrored over a vertical line. So you click the mirror function there. First, it asks you to select a mirror line. So what we're going to do is select this horizontal line that's running directly through the middle of our quarter mesh right here. So I'm going to select that line. And then it says, what do you want to actually become mirrored? And I want this lowest line down here. So we're going to select that line. And then you should see another horizontal dotted line cutting across that looks perfectly perpendicular, or perfectly parallel and equal spacing to the bottom line down here. Click the mirror. So now we have two of them. Basically, what I'm doing is I'm making it so that now this connector here and this connector that we're going to make right here are exactly equal to each other. What's nice is, because I mirrored it rather than create a new line, if I edit this and move it, make it shorter, make it bigger, maybe space it away from this, they both move because I leveraged the fact that they're symmetrical. Does that make sense for people? Why it's better to mirror things rather than just like create a new line. Awesome. So from there, what we're going to do now is click your line function there. Go ahead and click this last unit there that we've got. Arbitrarily click up to there. I'm going to drag this line over so that it's lined up with the dotted line, and then click it down over here. Oh, I'm going to make sure that it's actually vertical there. Let's hit escape. Again, we're going to make sure that they're equal to each other. Cool. And then we're going to also dimension one of these lines so that from the midpoint of the unit, it's exactly 3/4 of a millimeter, 0.75 millimeters, and then everything should be black. So this is great. So what we can do now is we're going to trim the lines that we don't need. So over here, there you should see a little scissors function. If you don't see the scissors, you can click this drop down right where I'm pointing. You should see the options for trim, extend, and split, but we're going to use trim. So it's very similar to the trim feature in SolidWorks, but instead of power trimming where we just kind of like slice away what we don't want, we have to select the little lines, each of the line segments that we want to get rid of. In our case, we want to get rid of each of these little segments that we don't need anymore because we want this to be one solid piece. We're going to get rid of that piece and we're going to get rid of that piece. And if you did everything right, you should be able to just delete that without deleting the rest of the line. Similarly, we're going to go over here and delete this piece and delete this piece. People able to do that? And you can also start deleting some of the box because we're not going to need that anymore. You should see that it starts to turn actually red because things are unconstrained. Sweet. So now I've got this whole entire open piece right there. So what we're going to do now is actually, before we mirror it across, this is still sort of half of our unit. I'm going to delete this glass meshes that were completely open there. You know, nothing, everything should be blue, nothing should be filled in. What we're going to do is actually pattern this over so that it's completely, so we already have our horizontal pattern. Or actually, maybe we should mirror it first. We're going to mirror it first so that it looks like we have a full unit. So what we're going to do is find the mirror function down here. So you have mirror there. And you're going to select the mirror line, and the mirror line is actually going to be this bottom dotted line here. Click that. And then we're going to select this entire drawing. And don't worry if you also select the mirror line. That doesn't matter too much. So I'm going to click here and then just drag a big blue rectangle over everything. Let it go. It'll process for like half a second. Click front to zoom in. And then now you should see a full unit appear. And we're starting to look more like a stent mesh. I'm going to stop. Are people there? Anime is a superstar. Anybody else? Is anybody having trouble? Definitely now's the time to pause and we'll make sure that we're all on the same page. I'll wait another 2 seconds. Can everybody hear me okay? Great. Awesome. All right, we're gonna keep going. So now we've got this, 80% done mesh, right? So we've got this connector connecting these, each of these halves, and then we've got these two preparing to connect anything else that, any repetitions of this one unit that we've got there. So what we're gonna do is now extend this horizontally and then prepare to extend it vertically as well, so we have our grid. So I'm gonna get rid of the mirror function there. We like it, we love it. And I'm gonna click linear pattern here. In this case, what we want is this entire whole unit mesh. So I'm just going to drag a line over everything while I have a linear pattern selected. And again, I'm not going to be able to see anything just yet because it's pretty far away. So what we can do is, now we have to wonder what is our, what unit do we put in for the, instead of 25 millimeters so that they're exactly coincident with each other. In our case, we defined one of these units as 2 millimeters long. And because we extruded it 4 times, we know that this whole singular unit is exactly 8 millimeters long. So I'm just going to type in 8, hit return or enter, and now these 3 things should be repeated exactly perfectly, and you should see little triangles. Those are just dotted lines. Up here, click the green check mark, not up here, just click, click in the white space. And now you should see something like that. Thumbs up for people? Like a fat, sad face. If it
Can you just spend a second on just let people do this so that people can see what the lines need to be cut?
Sure. Any questions in the chat? Okay. While I give you guys a sec to make sure that you have all this, a couple of things to notice. So the things in gray right here, those are in gray because those are actually a fully enclosed surface. So we could, in theory, extrude this right now, but we wouldn't extrude what we want. We would extrude, these little like diagonal cookies that, are useless to everybody. So what we're going to need to do is actually just close up those corners, and the whole thing should turn. All right, Stephanie, all good. The whole thing should turn dark. So I'm going to go ahead and keep going. Is that all right for everybody? Great. And I'm going to click each of these open ends here. So click that line with the line tool, and then click over here. That closes that up. Zooming is a little weird on this browser, so I'm going to click that line down to this one, and you should see just the number 1 come up because we designed it so that it's exactly 1 millimeter apart. Then over here on this side, just click those 2 and then these 2 points, and now everything should have lined up exactly perfectly. Now, I'm noticing that we did mess one little thing up, and is that we actually have a solid line running through the middle of this, which is not quite what we want. So I'm going to go over to the trim feature here, and I'm just going to trim this middle line there, and we might have to trim it twice to fully get rid of it. There we go. Because we actually mirrored it on top of each other. So trim it twice. There we go, and then trim that guy twice.
So this whole part that you have right here, this is called the ring of the stent. And so essentially what we're going to do next is we're going to make a bunch of iteration of these that go vertically. And then we'll have like a sheet. And then with the sheet, we're going to wrap it around a cylinder, and that will make our stent.
Yeah, this is great. So everything should be dark. Does anyone not have that? Because I know it's a little finicky if you accidentally left anything open. Definitely let us know, because we want everyone to be able to walk away with like a beautiful stent.
What did you do to get all the shapes to fill in?
So first thing you want to do is make sure that these ends are closed up and that there's no lines loose anywhere. So basically, if we have just like a loose line out here, OnShape's not going to know what to do with that. It's going to say like, what is this line doing out here? And it's going to try to extrude just anything that is closed up. So get rid of anything that is unnecessary. So you can delete that sketch entity. Make sure that these 4 are lined up. Make sure that these are lined up. So these top connectors. So just extrude, if you don't have one, draw a line from this point to that point, and then from this point to there. It's a little tedious to do one at a time. That's why that's why we did it before we linear patterned it. But there should be a solid line right there. Try that out, and we can always go back if we need to.
Quick question.
Yeah.
So if we mirrored it, why do we still have to like do both top and bottom? Like when you mirror it, you only mirror at that moment. And so any future edits would have to be done on both sides.
Do you mean when we mirrored like this top to get the bottom?
Yeah, so we had to draw those segments, but both on the top and the bottom.
That's a good point. So yeah, we mirrored it so that just basically so that we wouldn't have to create it again, because it already took like a couple of steps to make that top, and so by mirroring it, we just have like exactly what we wanted on the bottom side. And then we mirrored it first before we patterned it to the right, so that everything would, we knew everything was going to be good. Because what we could do, you could do it both ways, right? You could pattern it out and then mirror it. The issue is, if you mess something up on the top, now it's messed up all 3 times. Whereas if you mess something up on the mirror, you can just change the mirror and then it'll reflect on the bottom too. I'm not sure if that answered your question. But what we're going to do now is, and let me know if we can always go back to this part too, but we're going to complete the sketch. You should see it, just be nice and gray over here. What we're going to do now is click sketch 1, which we just created, and then hit extrude. And what it'll do is it'll preview a really fat, unnecessarily long, like claw thing, because it assumed for some reason 25 millimeters. We're actually going to want to use something just like 0.1 millimeters. Very, very skinny, or you can even do 0.5 millimeter, so 0.5. Actually, I'll do 0.1, so it's skinny. And that is the beginning of our mesh. Is anyone having trouble with the actual sketch? And if you're not, that's great. This is awesome. So hopefully you've got this, fun looking claw here. And obviously you can also sketch it out so you can have, 100 repetitions. It'll process a little slower, but you can have as many as you want. Just keep track of how many you have. So we've got 3 repetitions this way, and we're going to now repeat it vertically. So what you can do, I'm going to line it up to the front. Now we can also do repetitions on features. So what we have now, before we had a sketch, now we have a feature because this has some third dimension. This has some thickness. So we're going to click the linear pattern for the features. So you see these 4 little squares that now have some depth to them. And you should see this menu come up. So here, make sure new is selected, and then make sure entities to pattern is blue. Select the top plane of this. So you have the whole option selected there. And then in direction, click direction, make sure it's blue. We're just gonna click one of these vertical lines here. This is sort of like a reference direction for us. So I'm gonna click that vertical line there. Again, you can't really see anything because it's so far away, but it's actually already created a second version down there. So we know exactly that one of these units was 2 millimeters long. This was 2 millimeters long. This was 1 millimeter, and then each of these guys is 0.5 millimeter. So total, it adds up to 6. So one of these units is exactly 6 millimeters long. So if we change this to 6, you should see that they line up perfectly now. And then we can start to extrude our mesh as far as we want. So we can do 5 repetitions of 6. And we have that guy there. Or we can even do longer if we want. Let's do 7 repetitions.
Yep, and stents are always longer than they are fat. So you want to make sure that your vertical distance is bigger than your horizontal distance.
Yeah.
Another
Otherwise,
note is that when you make metal stents, you send it to somebody who specializes in doing this, and they laser cut the stent. So they use a flat sheet. They just laser cut it straight onto the flat sheet. So this would kind of be the design that you would send the person who cuts your stent.
I actually didn't know that. So then do they just like bend it and then solder it together?
Yep, that's it.
Wow. You have to be like a surgeon to do that. They're so small. It's crazy.
Yeah, there are people, I've read an article recently about how like an indigenous tribe was designing stents because like their specialty was weaving. And so they invented this type of stent, or somebody in the tribe invented a type of stent that was based on their specific type of weaving. It's pretty cool.
Wow, that's awesome. Great. So we're almost done. Now that we've got the grid, it's all a matter of, well, make sure you click the check mark, and now you should, once it processes, you should have this entire grid created in 3D space, which is really, really great. So now it's just a matter of, again, wrapping it around some cylindrical feature. And as Anusha said, we're going to wrap it this way so that it ends up being a nice cylindrical surface there. To do that, in things like SolidWorks or other CAD functions or programs, there's actually a program that lets you literally bend a planar surface up to a certain degree so that you can bend it into a circle or bend it into a some sort of dome. What we have to do actually is to wrap it around some pre-existing features. So in our case, we're going to create a cylinder. So we are going to remake visible. Let's go to the bottom plane here, the top plane. So make the top plane visible there. You should see everything get grayed out because we've got the top plane out there. And we're going to create a new sketch. I'm going to just click the top plane there. You can click out on the plane, or you can just click that there. I'm going to hide it now. And then over here, I'm just going to draw a basic circle anywhere you want, and then make it arbitrarily big. Cool. So we have to do some math now, and there's a reason we had the numbers line up as the way that they did. So remember that horizontally, each of those units was total 2 millimeters long. So we had one unit was 8 millimeters because it was 4. And then we patterned that 3 times. So the total width of this guy here is 24 millimeters long. So if we want to wrap it around the circle, does anyone know how big we need to make the diameter of our circle? Some geometry. Any guesses? Who knows the geometry? Who knows what the equation for the circumference of a circle is? How do you select the pattern direction?
2 pi r.
2 pi r, thank you. We're going to divide it by pi. So 24 divided by pi. So I just type 3.14. So 24 divided by 3.14, and that should give us exactly the diameter. So what was the question that we had there? I just like the pattern direction. Do you mean for the vertical pattern? This way?
Right.
So what you can do is first, so I'm going to click linear pattern again. First, you're going to select the underneath the pattern, make sure you just select the face there, and then click direction, and then you're going to select just one of these. Just hover over the edge, and it should highlight just the edge for you, as long as you have direction clicked. Does that work?
Trying.
And anybody else also feel free to ask questions. Because we're nearly done. So if you have a question or if you got stuck somewhere, I'd be happy to either jump in a breakout room, or we can just have you share a screen and we can all collaborate on making fun stents. And if you are comfortable with this, feel free to just like make your own design. Did that work, Kenny?
Yep.
Sweet. All right, I'm gonna get rid of this guy that we made. And I'm gonna go back to the sketch. I'm gonna edit it again, and then right click to do normal to sketch. Cool, zoom back in. All right, so we made it exactly 24 divided by pi. So it's 7.643 something. Now what we want to do is actually, we want to make sure that the cylinder that we end up making is tangent to this line down here. So I'm going to click on the constraints menu here, click on the drop down. You should find one that actually says tangent. So click tangent. So now we have to click two objects that we want to become tangent to each other. So we want the edge of this circle here and the edge of our mesh that we have here. So I'm just going to click the mesh. Sweet. So now it's actually perfectly constrained, right? And oh, I happen to click the center of the mesh too. So now that's why it's fully black. If you didn't click the center of the mesh, it might still be blue. There's nothing to worry about there. So I'm going to just click the check mark because now we have a circle perfectly on the mesh that we've created there. So that's great. So what we can do now is hit extrude, click on the sketch of the circle we just made, which you can click on over here, or just click literally in the sketch. And then it previews a random cylinder that we want to extrude. Now, make sure that we click new, not add. So you have the option to do new, add, remove, or intersect. Remove is if you literally want to remove a cylinder from something. It doesn't, or add is if you want to add a cylinder or something. In our case, because we're tangent, it gives you a little warning that says like there's no geometry change. It doesn't make sense to add this. What we want is actually a new cylinder. Now it turns gray instead of red. So that warning is gone. So I'm going to flip the direction using that little arrow, and I'm going to make this about 50 millimeters long. The length doesn't super matter as long as it's longer than the actual mesh that you have. And then we also want to go in the other direction too, just to make sure that we've covered on both ends. So I'm going to click this check mark for second position, and it actually extrudes it to 25 millimeters, and that's fine. So I'm going to click the check mark, and now we've got this giant tube that we're going to use to wrap our stents around. And actually, this is kind of similar to how you would do it in real life, right, Anusha? Based on what you said, you would laser cut this and then just wrap it around the tube.
Exactly, you would wrap it around some sort of tube.
Great. So does everybody see? Everybody can see that we're close to operation. We'll click the front plane there. All right, we've got a tube. Now,
Antonio,
yeah, what's up?
does it matter if the cylinder is in the middle of the stent or as long as it's tangent?
Yeah, as long as it's tangent. So if mine just happened to be in the middle, I didn't. I'm just smooth like that, but it was total accident. I think I just accidentally clicked the midpoint. But as long as yours is tangent to the surface, then you should be fine.
Thank you.
Yeah. So I'm gonna click the front plane again. So now it's important to organize this so that you're looking at it so that the cylinder is in front of the mesh, as opposed to looking at it, in my case, from the back. You can see that the mesh is in front of the cylinder. We actually want to look at this side. So cylinder in front of mesh, got our mesh in front of us there. Up on the top feature menu, you should see these two blocks that have little arrows. If you hover over it, it says transform. We actually don't want that one. We're gonna click the little drop down arrow, and we're gonna find the wrap feature, which is exactly what you would do in real life. We're gonna wrap something across something else. So here in the wrap feature, you've got three options. You've got split, surface, and solid. You actually want to click solid so that we create something new. And again, you want to make sure that new is selected. solid, new on the wrap. Wrap is over here. I'm gonna keep clicking this so that you can all find the wrap feature. Is anyone having trouble finding the wrap function? I always have trouble finding it. Great, okay, I'm assuming you all found it. So now what you can do, we're just gonna look at, make sure that one works. So I'm going to click making sure that tools is selected. Click the face of one of our horizontal units. If you do that, and then you go over, click target, and then click the cylinder, you should see some real thick accordion looking piece up here wrapped around the cylinder. That's sort of correct, but basically it's thick because on thickness we selected 2.5 millimeters. What we actually want is something like 0.1 millimeters. It'll load, and now you can see that we've got something wrapped around here, nice and tight. What you can do there is, I'm just going to click here again, basically just go down the line and click the faces of each of your horizontal steps. And there is a way to do this programmatically, but OnShape is a little finicky, so we're just going to click one by one.
And make sure the tools box is selected, not the target box.
Correct, yeah, that's important. Make sure tools is selected, otherwise it'll get really confused. We had a lot of trouble with wrap earlier. But as long as the only thing inside of target is the face of the cylinder, you should start to be able to preview the stent on the face like that. So I'm going to keep going, and then we'll go back and make sure that I answer any questions or maybe help troubleshoot for some people. So 0.1 millimeters is the thickness of our guy. We're going to click check mark, and then we've got what seems like the stent surface, a cylinder, a rod, and then the actual stent somewhere. It looks like it's engraved onto it. So what we want to do is several things. First of all, we're going to get rid of this. So we're just going to hover over just the mesh part, the grid. I'm going to right click and then just do hide all 7 or 5 parts, how many you have. So we didn't get rid of it, we just hid it. Similarly, we can't actually hide the cylinder. It would get rid of the entire thing. I'm going to hit the, also if you mess up, there's an undo function button right up at the top left, so undo. So we can't actually hide it because it'll hide all of it because they're connected. So what we can do is over here at extrude, this is kind of a janky way to do it, but it works. We can click this cylinder there. So click extrude, click the cylinder, we're going to click remove, and then you're going to click blind and come down where it says through all. We're going to click through all so that it removes all of it. And then we're going to click the check mark. And now you should see a beautiful stent has been created in 3D.
Woo!
Woo! We're ready to operate, doctor. Great. Okay, I can see everybody on the screen. So thank you, Simon. So let's back up. Was anyone able to get this far?
Can you open up the wrap one again, just so I can see?
Totally.
Thanks.
So let's. Show all parts. So here's the wrap. Did anybody have trouble with the wrap?
Mine just keeps saying wrap 1 did not regenerate properly, wrap failed.
All right, let's get at it. Let's go. Bye, Kenny. Let's go to. All right, I'm going to delete the wrap that I have. So I rolled that back. It's going to give me back our cylinder. I'm going to delete. I'm going to suppress the wrap. Great. Okay, so we're going to make a new wrap. So are you this far on me?
Yeah.
Great. So click on the wrap function. So first off, make sure that you click solid.
Yeah.
That. And then when you click tools, did you actually do this thing right here?
No, I clicked each one.
Oh, we clicked each one. Okay, so let's just do, instead of clicking each one, let's just click one of them. So click that face and then click target and then click this. Does it show you a preview when you do that?
Let me take out. Just click one of them.
Yeah,
No. Well, it doesn't do it in 3D. It wraps it and like shows the outline of it in orange, but it doesn't actually.
Is it like different colors? Is it like blue or orange? You said orange, right?
Like, yeah, it's orange.
Okay.
Deep orange.
So can you double check that you have solid selected, not surface here?
Yeah, it's solid.
So you have solid selected. Do you have? Is it on new or add?
Both of them do the same thing.
Did you extrude your mesh?
Yeah.
So
Yeah,
it should look bluish like Antonio's. If it's not extruded, it'll look like gray.
Oh, let me see.
Does your mesh have some thickness to it?
Yeah, because it's called extrude 1, or at least mine is. Let me make sure I made it thick.
Do you want to share your screen on my end? We can.
I'm not. So I'm on my iPad on Zoom, so I'm not.
Oh, you're doing. Wait, you're doing. Oh, I see. So you're on 2 computers.
Yeah.
If you want to email it to us because it's a cloud document, we can look.
No worries.
We got this though. We can do it. So, so
I mean,
you literally
use my camera and show you.
Yeah, that'd be great. Let's do that.
Oh, this is gonna be disastrous. Okay.
Well, this is gonna be great. Is anybody else having a similar issue? Because we know that the wrap feature.
Okay, can you see my screen? Okay, here we go.
Yeah, I can see it.
That'd be interesting. So wrap.
Yep. Let me do exactly what you're doing too. So wrap, solid, click that guy, target this guy. So you've got solid selected, you've got new, you've got add, tools, face. Do you have anything else selected, like trim to target or specify anchor points?
No.
What happens if you click the check mark right now?
It goes red.
Big sad, big sad. Let's see.
It might have to do with your diameter too.
Camera, so.
Yeah, what did you divide by on the?
On what part?
On the cylinder. What's the diameter of the cylinder?
It was the same as yours. It was like, I can't remember what it was. How do I?
You can click. You can right click and do edit sketch.
7.06.
Oh, okay. That's the issue.
Or 7.6. Wait, what is it?
Oh wait, what is it? 7.06 or 7.6?
7.6. Yeah, 7.
Let's see what mine is.
Sorry, it's really hard to read. Yeah, 7.639.
Can you do 7.65? I think this is gonna work.
And then.
Yeah.
Oh gosh. Oh, okay.
Bye, Katie.
Okay. Yeah.
Yeah. Okay.
Okay.
The reason that didn't work before is because we're just approximating what dividing by pi means. The wrap needs to wrap around something that's bigger than, so it can't overlap essentially. So even on mine, when I did it, I'm gonna unsuppress this guy. If you really like looked in and zoomed in, you will see a gap because I didn't like divide by actual pi because pi is irrational. But there's the little gap. But basically, it doesn't matter in our case because it doesn't need to be perfect.
That makes sense.
Yeah, I'm glad we fixed it live.
Yeah, me too.
Great. I'm gonna stop sharing and ask, what did y'all think? How was the workshop for the 4 people that are left?
Yeah, it was great. Thank you, Antonio. That was cool.
Yeah, and Anusha, this is totally Anusha's idea, and she was the brains behind the whole thing.
Thank you, Anusha.
No, thank you all for coming. I'm really happy that I got to share some knowledge.
This is fantastic.
This was a great workshop. Also, the slides are so good. I was so impressed.
Thank you.
Yeah, so I'm texting me like 5 times that the slides were so good, and I was like, I know it was all me.
Some was the best designability though. The poster was beautiful.
Great. I'm going to stop recording. Thank you, everybody.